Hello and welcome to Vodcast 12.7. This is the final Vodcast for Chapter 12, and in this Vodcast I will overview fog. Fog! What's that all about? Well, a very important definition to know is that fog is a cloud with its base at or near ground level. It's considered an atmospheric hazard, and you probably know all about that if you have ever had to drive through it. There are two particular ways fogs form. The first is what's known as radiation cooling. And radiation cooling requires clear night skies and high relative humidity. To explain it as simply as possible, on a cloudy night, the clouds can act like a blanket that traps heat. But on very clear nights with no clouds around, heat energy can escape the surface very easily, and land will cool rapidly. And it's that radiation cooling that can trigger the formation of certain fogs. Now the other way that fogs can form is if air becomes saturated through the addition of water vapor. And this particular process is what's known as evaporation fog. Shown on this slide is a really pretty picture of what's known as steam fog, and steam fog occurs when cool air moves over warmer water. Steam fog is most common on crisp, clear autumn mornings because the water is still relatively warm, whereas the surrounding air can be quite chilly. There are three specific types of fogs that are caused by cooling. The first of the fogs caused by cooling that I'd like to discuss is radiation fog. As mentioned previously, Earth's surface can cool rapidly at night if the sky conditions are clear. And with no clouds around to trap heat energy, air near Earth's surface can cool relatively rapidly. And if that air near the ground gets cooled to the dew point temperature, radiation fog can form. The second type of fog caused by cooling is what's known as advection fog. And advection fog occurs when warm, moist air moves over a cool surface. Shown in the picture at the far right is advection fog, which commonly occurs in San Francisco. And what essentially happens is that warm, moist air will be chilled by contact with the surface below. And that surface very often is cold water. Well, when that warm air that contains a lot of water vapor gets chilled, it can reach the dew point temperature and condensation can occur. And the final type of fog that I'd like to overview that's caused by cooling actually brings into play adiabatic cooling. Most fogs do not require adiabatic cooling, because these are clouds that occur at the ground level. But upslope fog will occur when humid air moves up a slope. As discussed in a previous podcast, when air is forced up, say, a mountainside, it will expand and cool adiabatically. And if that air cools to the dew point temperature, we can see the formation of fog. The main difference between upslope fog and clouds formed via orographic lifting is that upslope fog will occur very close to the surface, whereas the cloud formation that will occur via orographic lifting will occur relatively high in the atmosphere, when compared to the level that fog forms. The final type of fogs that we'll consider in this podcast are evaporation fogs. There are two primary types of evaporation fogs, the first of which is known as steam fog. I showed a picture of steam fog on the very first slide of this vodcast, and steam fog forms when cool air moves over warm water. When this occurs, the water will literally have a steaming appearance. It'll almost look like the top of a cup of hot coffee. Steam fogs will be most common in the autumn months in the morning over lakes and rivers. And the reason is, in the autumn months, the water will stay relatively warm. Because remember, water has a very high heat capacity. And what that basically means is, it takes a lot of energy loss or energy gain to make water's temperature change. But during the autumn months, the air can be quite cool. So if cool air moves over warm water, you can see the development of steam fog. The mechanism by which steam fog occurs is that evaporation will occur off the surface of the warm water. And remember, if the air is cool, it doesn't take a whole lot of water vapor content to make the air reach saturation. So any of that warm water that evaporates off the surface will be added to the water vapor content of that cool air just over the top of the surface. And then once that air becomes saturated and you reach the dew point temperature, voila, you have steam fog. The second type of fog that's considered an evaporation fog is what's known as frontal fog. And what's really interesting about frontal fog is that it occurs through the process of frontal wedging. This picture shown on the screen is probably familiar to you. We know that warm air is less dense than cold air, so if cold air runs into warm air, the warm air will get forced aloft. When that warm air works its way upward into our atmosphere, it can cool adiabatically, form clouds, and those clouds could form precipitation. Now with frontal fog, something interesting occurs. The clouds form precipitation, but as that precipitation falls towards Earth's surface, the raindrops evaporate. Now, raindrops that are evaporating are going to add water vapor content to the air. And especially when those raindrops are falling through the cold air region, where cold air doesn't have as high a capacity for water vapor before reaching saturation, you can see the formation of frontal fog. Okay, that concludes this video podcast, and that concludes Chapter 12. Our focus in Chapter 13 shifts to the atmosphere in motion.